All right, here we go. This is video 2, and so in this video, I'm going to really attempt to do dividing monomials as well as the zero property, okay? So in this one, when we say the dividing of monomials, we're saying we use the quotient rule, all right? And so the quotient rule, if I go to my cheat sheet real quick, I'm basically going to do subtraction, okay? So like if I look at this one here, we got 27x to the 5th, 42x. So when I reduce, I want to say 3 goes into both of these. I'm trying to think if there's a higher number. So I'm just go with 3. So if 3 divides into 27, because I have to simplify and reduce this fraction, that's going to leave me with a 9. Still got x to the 5th. If I divide this by 3, then I'm going to get, 14. No. Yes. Sorry. Yeah, 14, and I think I'm done there. If I mess up on the number part, forgive me, but I want to say that's it. Like, I can't reduce that. Again, 3 went in there 9 times, and then 3 went in here. Just doing it in my brain. 1, 3, yeah, 12, 14. And then I still have that x to the 1. And then I have to subtract when I group these two together. There's a 1 here. So 5 minus 1 is 4. So the final answer is 9, x to the 4th over 14. Now I want to show you this one just because that'll bring me into what the zero property is about. But notice right here, this has to do multiplying with the power rule. So I have to multiply. You know, this is a base raised to a power raised to another power. So I have to use this one, which is the product rule. So I'm going to do multiplication. So that's y to the 4th. And there's nothing to do to the bottom. So notice that for this one, I would have y to the what? Because it's quotient, 4 minus 4, which has to do with this one. But when I do 4 minus 4, I get 0. All right, which leads me now to the final answer. The answer is 1. So if you go now to the zero property or zero exponent rule, you'll notice that any base raised to 0, this can be a 5 raised to the 0, this could be even with a parentheses, negative 10 raised to 0, or s raised to 0, or g, it's always 1. All right, so that takes care of all the major 5 properties, if you can see there. And then I did also post a snippet or an image, and I'm going to post another one, that's another cheat sheet. So again, just use all these as resources or something to reference. All right, so let's jump into this worksheet here, okay? So I'm going to just jump around, and I'm going to do number 2. I'm going to do number 6. Then I'm going to jump down to the next section, 7 through 12, and do 2 of those, and okay? All right, here is number 2. Very straightforward. I have k to the 12th over k to the 2nd. That's k to the 12th minus 2. The answer is k to the 10th. Here's number 6. Remember, all I'm doing is subtraction. They have the same base and different powers, and it looks like it's set up like a fraction. For number 6, it's x to the 20, y to the 9th, that's a z to the 2nd, and then down here, x to the 5, y to the 9th, and then z to the 1, but we don't write the 1, but I just did it so y'all can see it. So when I begin to group these together, I have x to the 20 minus 5, y to the 9 minus 9, z to the 2 minus 1. All right, now when I just finish it off, again, these are both 9s. So now I have x to the 15th, y to the 0, and then z. But again, because this right here has to do with the zero exponent rule, anything raised to the 0 power is always 1. Okay, so I'm basically just gonna, I'm not gonna say it's canceling out. He's just gone because he's 1. So the final answer to this is x to the 15z. There is no y term. Be careful with that. All right, let's keep going. Let me go to number 8. I have 14 r squared s to the 2nd, 7 rs. All right, so again, do not overcomplicate the number parts, right? The parts with the coefficient. So 14 divided by 7 is just a 2, so I'm going to put that in the numerator. And then I have r2 minus 1, s2 minus 1, So the final answer to this, there's nobody in the denominator. It's just 2RS. Maybe it makes you want to say the alphabet. QRSTUV. Okay? And I'm singing because my son's been singing the alphabet all for a week now. All right? Let's try. I guess I'll do number 10 just because it has those negatives. So I have negative 15. All divided by. Okay. All right, and here's what we have here. We know that a negative divided by a negative is a positive. 15 divided by 3 is 5, so I got a positive 5 in the numerator. And then I had basically 6 minus 5 for my x term, y, and then I have a 5 minus 5. And here we go, z, 1 minus, squeezing that in, 3. So for this one, I still have the 5. This is going to be 6 minus 5, which is 1, so we'll just put an x. This is 5 minus 5 is 0. Just take your time. And this one is 1 minus 3, which would be a negative 2 for z. So the final answer to this is 5x. I don't have to do the y because y to the 0 is 1. But this z is unhappy with that negative exponent, so he's actually in the denominator with z squared. So that's the answer for number 10. Remember, you can pause the video. That's pretty much it for dividing. And again, you can see the zero exponent rule comes, around as you run into it. So let's look at the mixed practice, which is the bottom part now, 13 through 16. I'm just going to do number 16, and the rest you guys will fight with them in class because I would like to go to the second page. The second page has, with the mixed practice, have a lot of them. I'll do like 2 or 3 of these and then cut the video here. All right, so now let's do number, I think I said 16. So for number 16, I have, make sure that you study this stuff. You go over it, you watch the videos over and over again. 2, we're going to answer parentheses. 2c to the second, d to the third. Careful with your signs. Okay, so just want to show just real quick another alternative is notice that I told you can call all of this one base, the stuff inside of here, right guys? So you're going to do 2 raised to the 4th. C, this is 1 times 4. And then of course for the d to the 4th, you're going to multiply here. Okay, so everybody gets raised to this one, and then if you happen to have a power on your exponent, you do multiplication. But what if I told you that again, just expanding this right here is being multiplied by itself 4 times. So I'm just going to show it a little different. So if you were to write this out 4 times, you also can look at it this way. Everybody see that in the numerator? So this would be 2 times 2, which is 4, 4 times 2, which is 8, 8 times 2, which is 16 for the numerical part, the coefficient. And these c's have 1s, so now I'm using the product rule. So I'm doing basically, 1 plus 1 plus 1 plus 1, so c to the 4th. And then 4 plus 4 plus 4 plus 4, that's going to give me 16. You don't have to do that. I'm just showing you that's what happens if you just want to make sure on the quizzes and the exams, do what you got to do, make sure you get it right. All right, on the bottom, same thing. On the bottom, there are 2 of these. Or again, you can put, I'm going to show it again 2 ways. You can put 2 squared, then you turn around and say c squared raised to the square, d cubed raised to the square. So that way you can really see on your cheat sheet like, oh, hey, I'm going to multiply those because it looks like this one. Whatever you got to do, I'm trying to go through it very thoroughly. All right, but again, you could also expand it out 2 times. And you could say, oh, on the bottom, I got 2 times 2, which is 4. And then right here, I'm doing addition, right? C to the 4th, and then I have addition here, d to the 6th, which again, it comes out the same that I did, 2 times 2 is 4, 3 times 2 is 6, and then this right here was 4. See it? Final answer, I'm doing 16 being divided by 4, which is 4. Here, I'm applying the quotient rule, which means I have to do subtraction. So this is c to the 4 minus 4, which will be 0. And then I have d to the 16 minus 6, final answer. C to the 0, d to the 10th. That c to the 0 becomes a 1. And that's it. This, again, was number 16. All right, so now let's get to the second page. And they get pretty nasty, okay? I'm gonna jump around quite a bit. So I'm gonna do number 23. I'm doing the scarier ones. The rest you'll do it in class. And again, I'm gonna take some grades tomorrow. So let's do this one. All right, so I'm going to just stay true to, again, just using the rules. So again, this becomes 2 squared, and then I have x to the 3rd squared. I'm going to multiply. So this becomes 4 x to the 6th. For this one, it's 3 to the 3rd, and then I have y to the 4th raised to the 4th. I'm sorry, 4th to the 3rd. Sorry. So then 3 times 3 times 3 is 27. Y to the 12th, I have to multiply using the power rule. Then on the bottom, I'm just going to leave it like it is. Let it do there. So I'm going to transfer that down just like it is. But now I'm going to focus on the numerator, and I ask myself, hey, what's 27 times 4? So again, I think that's what? 28, 8, 9, 10. I got 108. 108. But I got 108, and I still have that 12. And now I'm grouping together my x's. So I got x to the 6 minus 4, y to the 12 minus 5. So the question now becomes, how many times can 108 divided into 12? Let's get my calculator real quick. I should know that one. I think it's 9. Hello. Yeah, it's 9. So when I do this division, I get 9. And this is x to the 6 minus 4 is 2. And y to the, I want to say this is 7, 8, 9, 10, 11, 12. Yeah, y to the 7. This is number 23. Pretty not too bad. Thought it would be worse. Which 24 is similar. All right, so now I'm going to jump down to number 26, which looks like 25. All right, so for number 26, is I have 8 and again, just real careful how everything lines up. Okay, so I'm going to just leave this part back here alone, drop it down, 'cause nobody or nothing's going on back here. I'm just focused over here on the front. All right, 8 times 3 is 24. And I know that since I have those r's, I'm going to group those together for r to the 5th and r cubed. So I know I'm going to do addition there. So that's r to the 8th. And then I have s to the 2nd, s to the 4th. And I'm going to add those two together. I'm using the product rule, which says to add those, that's s to the 6th. And on the bottom, I have 12r s to the 4th. So now I got to apply the quotient rule. So when I group my r's together, I'm going to do subtraction. So again, and I'll show you that part. But again, I first do 24 divided by 12 is 2. And this is r to the 8 minus 1. And then, of course, for the s's, using the quotient rule, group those together, and I have s to the 6 minus 4. So this is 2, r to the 7, s to the 2nd, plus I drop down that other term, and then what do you know? This is that part about adding and subtracting monomials. So I can't stress to you enough, pay attention to this, is that this back here, those variables and exponents there, they match. So there's nothing to do to this part, but just do 9 plus 2, 11. Combine like terms. All right, that takes care of that. Yep. And then I feel like, just to be fair, you just have to take your time. But I mean, I'm not going to lie. I mean, I see it that, 28 and 27 are pretty tough. I'm going to let y'all fight through those in class. If you ask me, I will do one of them just so we do that maybe as a warm-up. But when you come in, you must watch this video, okay? Your in-class assignment will be to complete all of the problems on here, and then we will check it for a grade. So make sure you watch and understand this video. And again, I don't mind that the ones that are really tough on this one, like 27 or 28, we can do together in class before I let you guys get started. That ends this video where, again, we did go over dividing monomials, which was the quotient rule. And then we also, with the subtraction, but we also ran into some zero exponents. All right, guys, I'll see you later. Make sure you get all your homework done. For pre-AP tomorrow, remember that homework number 1 is due. And I want to say I also gave you guys homework number 4. Not sure, but I think y'all have 2 homeworks due because y'all had a 4-day weekend. All right, and then for Algebra 1, the normal group, you guys just make sure you get done whatever I assign, which I think is homework number 2. All right, see you guys later. Bye-bye.